I'm going to take you through this review. We already had a quiz on centroids, so this quiz is going to consist of the other 3 points of concurrency. Okay, so you will have this sheet right here. So the first part of the quiz, nobody should get wrong because you can have this out to refer to. So if I mention, okay, the point that's equal distance from the vertices of a triangle, you're going to see from here this point to each of the vertices, it's the same distance, and that is a circumcenter. So now this will be multiple choice. All you have to do tomorrow, or when you take this quiz, all you got to do is circle the correct answer. Okay. So then I ask the distance from the vertex to the, and then you read this about 2/3. So this is the one we already had a quiz on, but we know it's a centroid. I read it's 2/3. So the longer side, the longer piece is 2/3 of the entire median. That makes this smaller piece a third. Okay, but this is a centroid. Okay, the next one, it uses medians. Again, that is a centroid. I tell you right here, it's a median. You find all 3 medians. Where they intersect is called a centroid. Okay. So the point of concurrency that it's perpendicular bisectors, that is our circumcenter. You read right here, the first one talks about perpendicular bisectors. You find all 3 for each side of your triangle, and that is a circumcenter. Okay. Point of concurrency for the lines containing the altitudes. So with an altitudes, that's the last one, and that is called an orthocenter. So again, if you read anything about an altitude, you will select orthocenter. I see that right there. It's altitude. It is the orthocenter. You're finding all 3 to find the orthocenter. Okay. Bisector, that is going to be the incenter. Okay. And what's special about an incenter, you're going to see if you bisect all 3 angles, you are going to find a point where it's equal distance to each of the sides. And that's what I ask right here. The equal distance from the sides of a triangle, that also is the incenter. Okay. So expect that, but I'm not making you memorize anything. Just refer to this sheet to be able to help you understand the answer. Okay, now the rest of this is we're just going to put this in action. I am told that we have a circumcenter. So this point right here, I read that a circumcenter, what's special about a circumcenter is this distance is the same. Okay, so the fact is, I'm telling you, this is 11. They're all going to be 11. Okay, so for GC, I need you to realize, oh, and this is the one we need the Pythagorean theorem, by the way. So right here, I have a little right triangle. We talked about a squared plus b squared equals c squared. The one leg is 6. Doesn't matter which one you call the a or b. So I'll just replace the a with a 6. We will solve for b. That'll be GC. And we know the longest side is 11. So you can just pick up a calculator. When they're separated by the equal sign, you type in your hypotenuse squared minus the leg squared. And in this case, we'll get 85. We're going to see that I never slowed down. I'm just realizing that you did not see this. But sorry, I'm looking at this problem right here where we describe the circumcenter, and then what we're going to use is the Pythagorean theorem. So we said this was 85, therefore b is the square root of 85. So if you ask the calculator, hey calculator, what's the square root of 85? It's going to tell you it's about 9.22. Okay, so if this is 9.22, AC is going to be double that. So this also would have to be 9.2. Add them together, or simply double, you're going to have 18.44. Okay, so now I ask for BD. And you just have to realize the distance of a circumcenter, it's the same distance to each of the vertices. So this 11, it forces BD to be 11. Okay, so hopefully that is real easy. Let's look at the next page. Okay, you can see that. So the next page, we are dealing with an in-center. So now this also happens to be a circumcenter because they're also telling us the distance to each of the vertices is also the same, but they tell us up here it's an in-center. So all these distances must be the same, okay? And what makes it how we actually find the in-center is we bisect all these angles. So we're going to use that to help us. So the first question I ask is, what is BC? So this length right here, and I tell you, so I'm just going to label everything. I tell you DC. So DC is 4, and I tell you that GF is 5. So you're going to automatically know that each of these are going to be 5. Okay. And I also tell you that angle ABC, so ABC, this whole thing is 50. And since we're going to cut it in half, we're going to know that these are going to be 25. So I'm going to label those right away as 25. So the first question I ask is BC. Okay. So what you're going to see is this is a midpoint. So this and this are each 4. So we're going to just simply double 4 for a total of 8. Okay. Then the next thing we need to realize is I'm only asking for this small angle. ABF is half of 50, which is 25. That's where the 25 degrees is coming from. And then when I ask for the distance from G to E, it has to be the same distance as G to F, same distance from G to D. They're all equal distances. So this is a 5. Okay? That's all I need you to understand when it comes to an in-center. Okay, let me make sure I scroll my paper down so you can see this next problem. Once again, we're dealing with a circumcenter. So again, if you look in your paper, a circumcenter, the distance from the circumcenter to each of these points, they're all the same. So I know they're all going to be 9. Okay. So I know that right away. And I'm going to set up in a little equation. We also have a perpendicular bisector. So these two things, this side and this side, are going to be equal. So I'm just going to set this segment equal to 21. I'll distribute. I'll subtract 9. So when you subtract 9, you're going to get 21 minus 9 is 12. We're going to see x is 4. Okay. And it should make sense. If I plugged in a 4 here, 4 plus 3 is 7. 3 times 7 is 21. So we also know that's going to be 21. And then I need to set up a problem where I'm finding what y is. Okay. So we're told 4y minus 3, this right here, we know this segment has to equal 9. So 4y minus 3 equals 9. This will be very easy to solve. When I divide by 4, I get a 3. Okay? So then to finish this, I am asking for ER. Well, we already know ER must be 21. Okay? And then KN, K to N, that distance must be 9 as well. So they're all 9 units away from the circumcenter to the vertex. So we know that's 9. And then finally, RN. So RN, so from here to here is also 9. Okay? That's what you're going to be looking for. So again, use your little chart to make sure you understand what I'm going to be asking. Okay? Here we have an in-center. So what we're told about the in-center, it's this distance. So a perpendicular distance, all this has to be the same. So again, has to be 90-degree angles. Technically, that should have been marked as 90-degree angles, but the distance from the in-center to the sides all have to agree, okay? So in this case, I am asking you to solve for GT, and I tell you, I do tell you that they're perpendicular, so we can fill in those 90-degree angles, and let's label GR, so the distance from G to R is going to be 7, which will force all these to be 7. Okay, so from G to T has to be 7. There's nothing to solve. And then I also then let you know that this angle B, where is it? BAC, this whole thing is 60, which will force each of the smaller angles to be 30, because for an in-center, we are taking the angle bisector. We're cutting each angle in half to find the in-center. So this is just simply 30 degrees, okay? For number 16, what we're gonna see is we have an in-center. So again, all these must be the same, okay? And we're also, I even show you that I'm bisecting the angle. So what you need to realize is I am telling you ABC. I am telling you the big angle is 6x minus 4. And then I tell you ABI, the smaller angle, is 2x plus 10. So what you need to realize, the big angle must equal double the small angle. So that's how we're going to solve for x. So just make sure, big angle, if that was 100, that makes this 50. So to be able to get 100 equals 100, I would have to double 50. So let's solve for x. This won't take long. All the equations on your quiz should be very easy, just basic algebra to be able to solve. When you subtract the 4x, you get 2x. When you add a 4, you get 24. When you divide, you get 12. Okay, so x is 12. So then I actually want to know what CBI is. So C and then BI, this right here, all I need to do is plug 12 in up here. So we're told if I take this, plug in a 12 into the smaller angle, 2 times 12, that's going to be 24 plus 10. 24 plus 10, we're going to see that angle has to be 34 degrees, okay? The big angle is going to be 68 degrees. If I ask for the larger angle, if I plugged in a 12 here, I would have 68, okay? So just make sure you answer the question that's being asked on your quiz, okay? And that leaves us the last question. Now, I'll mention it right now. So what you're going to also see, I will have a section. So if you're listening to this, you will have a section from your last quiz based on a centroid. So this was a question I gave on the first quiz where I am telling you T is a centroid. So what you need to make sure you go into the quiz on Thursday to know that if I tell you the entire length of a median, the smaller piece is a third of that length, and the longer piece is 2/3. Okay. So again, it's something a lot of people did very well. The problem that most people got wrong is when I tell you this piece, AT was 9, the relationship between the big piece and the small piece, you just take half of this. And a lot of people didn't want to take half of an odd number. So a lot of people did not have the 4.5, okay? So please make sure you understand what we do to find the centroid. The centroid is the medians, which forces these two, this F, and then the U is the same as U, then the N, because it's the midpoint, okay? These two segments have to be the same. This segment and this segment has to be the same. And if you're dealing with the median, just remember, the longer side is 2/3, the shorter side is a third. Okay, very easy questions to answer. Okay? So then the last problem, you have to, and I apologize for your version, it was very hard to see the markings. So I'm going to put some markings in here on the test. It's quite easy to see. So we need to plot -2 up 6. 1, 2, 3, 4, 5, 6. So right about there is our point Q. Then I'm going to go -2, 0, which is my R. And then I'm going to go 1, 2, 3, 4, 5, 6, which is S. Okay. And I'll try to make straight lines the best I can. And like I said, this will be clear. The grid will be visible to you on your quiz. Okay. So I am going to have on your quiz, I'm going to ask for the midpoints for each. Okay. So I actually want you to list the midpoints. So we'll do QR, we'll do RS, and we'll do QS. So QR, you can look right here, or you can just see that where it's going to be located, but I'm going to actually do the math here. So if I add my x's, I get -4. Half of -4 is -2. If I add my y's, 6 plus 0 is 6. Half of 6 is 3. I'm going to go over -2 up 1, 2, 3. So there is the midpoint for QR. For RS, again, you could just count the blocks, but I'm going to do the math. So RS, I get 4. When I add -2 plus 6, I get 4. Half of 4 is a 2. When I add zeros, I get 0, and half of 0 is 0. So I know my midpoint is at 2, 0. Okay? And then finally, QS. -2 plus 6 is going to be 4. Half of 4 is 2. And then 6 plus 0 is going to be 6, but half of 6 is 3. So when I plot 2 up 1, 2, 3, you're going to see it's right there. It has to be on your side. So if for some reason you calculate the midpoint and it doesn't appear to be on your side, you made a mistake. So now to find the perpendicular. We already found the bisector. The midpoint is the bisector cutting your side in half. When it's a vertical line, you make a horizontal line. So that's going to be real easy. When it's a horizontal line, you make a vertical line. Okay. And as soon as you do that, you're going to know what the circumcenter is. The circumcenter is 2, 3, but I will ask for the slope of the diagonal. So I'm going to ask, and you have to fill this in, for the slope of QS in this case. So when you look at your Q, I have the slope formula, and I look at my S, I must subtract my Y values. So I'm going to write 6 minus 0. It's Y minus Y. Since I started with this y, I must start with -2. You can't all of a sudden switch your x values. It's going to be -2 minus this x value. And when you clean that up, you're going to have -6/8. We expected it to be a negative slope. It's going downhill. I can reduce that to -3/4. Okay, that is the slope of that line. If you count the blocks, you're going to see down 3/4 is describing the steepness of that side. So to be perpendicular, okay, make sure you can see this, to be perpendicular to a slope of -3/4, I must do the opposite reciprocal. So I must flip it and make it positive. So this is the slope that I need to use. So I'm just going to start right here at the midpoint, and I'm going to count 1, 2, 3, 4 up, and I'm going to estimate 1, 2, 3. Put a dot right there. When I connect those, you're going to see this is a 90-degree angle. Okay, so that is how we find the circumcenter by hand. Okay, so expect something very similar on your quiz. You will have a vertical section and you will have a horizontal section. That should be real easy to be able to do the perpendicular bisector for that. But then the diagonal, I need the slope and I need you to do the opposite reciprocal to force a perpendicular bisector. Okay, so that is your quiz. That took 20 minutes to go over. Make sure you understand all those questions. Look back over some of the notes and stuff, and you will be more than ready for this second part of this quiz. So in the past, we just gave one big quiz on all four. I broke this quiz up to make it a little bit more manageable to get done in a timely manner. So this quiz should not take the entire period, but you can have the period to finish it. So thank you for watching. Make sure your practice is ready to hand in, that you checked all the answers. The answers are also in Schoology along with this video. So take care. Thank you for watching.